All right, so I want to do things a little different. This is practicing taking derivatives, but this time I want to give you guys time for you guys to start, like a head start. So don't worry, YouTube, if you're watching this via YouTube, I'll just edit the 2 minutes out and then we'll go right into it. So if you want to practice before we do it, maybe pause it a little bit. So yeah, no, I am going to put a timer, but we'll see. All right, guys. So try number one. I'm going to give you guys a 90-second head start. Is 90 seconds a good time or 2 minutes? Okay, 2 minute head start, and we'll see if it's 2 minutes is too much. So I am putting the timer now. And there's the timer. Was that enough time? Or do we need more? Okay, so it's enough time to get started. Okay, so the first thing I would have done, guys, it wants a derivative. The first thing I would have done, I would have rewritten it. Cosine, that's just 2x squared, doesn't stay, there's nothing different there. But this one is cosine x to the 4th power like that. So this one is a combination of product with chain. So this is first, this is second. Did we do that? If you did that, you're winning. So here we go. Y prime equals first. So I'm going to say cosine of 2x squared times derivative of the second. The derivative of the second, or the one that I underlined twice, is 4 cosine x to the 3rd power. Am I done? Times, what's the derivative of cosine? Negative sine x. I will put it in parentheses, guys, so it doesn't look like you're subtracting. And then I'm going to close it. Plus second, that's just cosine of the 4th, times derivative of the 1st. The derivative of cosine is a negative sine. Put 2x squared, but chain rule, times 4x. Did you guys get it like that? From there, you can make it a little simplified. So the way, I think on Delta Math, you don't have to simplify. You could just type it in like this with your parentheses. But I would, let's see, here's how I would leave it. So I would go negative 4, because there's negative right here, right? And then there's a 4 there. Negative 4 cosine 2x squared cosine cubed of x. And then I still have a sine x. Plus, oh, no. Sorry. There's a minus there. Minus 4x cosine of the 4x sine 2x squared. There it is, guys. There's my answer simplified if I wanted to simplify. I thought I was going to need more room, but oh well. Can you factor out a 4? Yes. Can you factor out a negative 4? Yes. Can you factor out a cosine? Depends how many you want to factor out. You can factor out 3 of them. So yeah, so there's a lot of different answers, but I think on DM, you can just type it in exactly how you got it. Like you can just type in the rule. That makes sense? Yeah, kinda? Virtual class, you guys okay? Yeah, I put the language that DM had. That's the language that it has in any form. All right, take another 2 minute head start. See if you guys can do this one. And go ahead and get started, guys. All right, here you go, guys. The first thing that I would have done before doing anything is rewritten it. So did everyone rewrite it to that? It's the 3rd root. So this is a combination of chain rule with quotient rule. So here we go. Y prime, bring the 1/3 down, 1/3, 5x cubed plus 4 over x plus 2. Leave the inside alone. Raise it to the power negative 2/3. How did I get that? I subtracted from 1. I subtracted from 1/3. 1/3 minus 1 is negative 2/3. Are we still okay? And then from there, I got to do the derivative of the inside. Now, when I do the derivative of the inside, what rule do I got to use? Quotient. Bottom times derivative of the top. What's that? 5 times 3, 15x squared minus top times derivative of the bottom all over bottom squared. They didn't ask to simplify. I could leave it in any form. So there it is. I'm going to leave it alone. I wrote a lot of space in case I needed to simplify, but they didn't bother, so I didn't bother. Are we okay right now, guys? I would just leave it like that. Yes. Guys, are you guys okay?
I have a question.
Yes, ask.
So why did we have to find the derivative of the inside?
That's chain rule. You still have x's in the inside, so you got to take the derivative of the inside.
Okay.
So you know what? Let me ask you something else. You know, every time you're doing this, every time you're taking the derivative of this, you're actually still finding the derivative of the inside. So there's a side note. Y prime equals, the derivative of cosine is negative sine x. And then the derivative of x is 1. See, so that's why we don't even talk about it. And to be very honest with you, it's actually 1 times dx dx. Because I took the derivative of x with respect to x. But dx dx is just 1. See? So that's why, so we're always doing chain rule. You just don't know it that we're doing chain rule. So yeah, you got to take the derivative of the inside because this is still changing with respect to x. Did I answer your question, miss?
Yes.
All right, guys, let's try another one. This one just wants derivative. Uh-oh, cosecant x. Go look at your notes. All right, take 2 minutes. You can if you want. I already started the timer. Oh. Maybe you guys didn't need that much time. Oh, you didn't finish? Okay. So, no, it's probably right, miss. Have faith. So the first thing I would have done, guys, I would have written this as cosecant x to the third power. And now I'm ready to take a derivative. So write f prime of x. I bring the 3 down. I leave cosecant x alone to the power 2. What do you think, Mazuka? Do I leave it alone?
Leave the cosecant x alone?
Yeah, what do I do next? Am I done?
No,
Or
you have to find the derivative of the inside.
that's right. I have to find the derivative of that inside. What's the derivative of cosecant x?
Negative cosecant x cotangent x.
That's right. That's the derivative here in America. Actually, that's the derivative everywhere, just not just here. And then that's it, guys. If it would have been cosecant of 5x, we would have done something about it. But no, that's it. This we can simplify. Let's see. Let's simplify it. 3 cosecant squared x. There's a negative here in the front. Cosecant x, cotangent x. We can simplify it even more. These two are being multiplied. Negative 3 cosecant cubed x, cotangent x. There it is, guys. All right, this one is going to require some pre-cal, and it's not even extreme pre-cal. So go ahead and take 2 minutes. Let me start the timer again. It's in quadrant 3. Do you guys get a tangent line? Do you guys get at least a point? All right. So you need 2 things for a tangent line, point and a slope. Let's get our point first. Plug in a 7 pi over 6. So f of 7 pi over 6 equals 3 tan 7 pi over 6. Don't worry. We'll put the square right here on the outside. So that's what I need. No, you don't need a calculator for this question. On the unit circle, 7 pi over 6 is right here. That coordinate is negative square root of 3 over 2, negative half. So there it is right there, Viacana. So now, 3, open parenthesis, it's y divided by x, so it's half divided by square root of 3 over 2. The negatives go away. Those cancel, and that's still being squared, remember? 3, 1 over square root of 3, and that's being squared. So when I square that, you don't have to rationalize it because the square root's going to go away anyways. So you got 3 times 1/3. Look at that. So you got a nice clean point. So my point is 7 pi over 6 comma 1. And now I'm ready to take a derivative. So now take dir. So f prime of x equals, remember this is the same thing as 3 tan x with a square on the side. 3 times 2 is 6. Leave the inside alone. Tan x times derivative of tan, which is secant squared x. We're still okay, guys? Now I'm going to plug in 7 pi over 6. 6 times tan of 7 pi over 6 is 1 over square root of 3. And I'll rationalize it a little bit. And then secant is the reciprocal of cosine. So cosine is a negative 2 over square root of 3. And I'm going to square that. Are we still okay, guys? So now let's see what I got. 6 times 1 over square root of 3 times 4 over 3. So 6 times 4, 6, 12, 24 over 3 square root of 3. Are we still okay, guys? How many times does 3 go into 24? 8 over square root of 3. Finally, I'm going to rationalize it. 8 square root of 3 over 3. So this is my slope. They wanted a tangent line, right? So tangent, and we're going to find out. We're going to put it on Desmos to see if it really is. Y minus 1 equals 8 square root of 3 over 3 x minus 7 power 6. Okay, you guys are going to have to give me all this info. You guys ready? All right, let's see. I find it so much easier to use Desmos without typing it in, using the digital. I'll just use the mouse here. Graphing calculator. All right, give me the function. Oh no, the original function. F of x equals 3 functions, 10, add an x on the inside. And let me move my parentheses so it's the whole thing squared.
Travis.
Yes, ma'am. Oh, I'm not sharing. Yes. Sorry, guys. I'll share it right now. Yeah, but I'm not sharing this part. Okay, now can you see?
Yes.
All right, so there's my function. And I wanted to call it f of x. Can I call it f of x? But I don't want to use my keyboard right now. Huh? Oh yeah, thank you, miss. F equals, yay, there we go. F of x equals that. All right, and then here's my tangent line. So I'm gonna say y minus what? Y minus, was it 1? Equals, and what was my slope? 8 square root of 3 over 3. And then open up parenthesis down there, or right there. X minus 7, oh, let me make it a little fraction. 7 pi over 4. Over what? Over 6, my bad. Yeah, oh, was it y minus 1? Oh, yeah, it is. I don't know why I was looking down there because they gave me a point there and that's x intercept. But yeah, it is, guys. Look, that's a point. Let me show the point. Point 7 pi over 6, fraction 7 pi over 6. And then let me move, comma, and then 1. There you are. There it is, nice and green. There's my point, and there's my tangent line. And yep, that definitely looks like a tangent line. Wasn't that cool, guys? I love what Desmos can do. Virtual class, are you guys seeing this? Can you believe it? Of course you guys can believe it. We're watching it. Tiff is not impressed. She's just looking like, okay. All right, let's continue. Now, she said she is impressed. All right. I probably should have done this one first because this is an easier one. You guys try number 5. Take 2 minutes. I almost forgot what we were doing until the timer rang. I'm like, what? All right, guys, here we go. I want another tangent line, so I need 2 things. So someone from the virtual class, tell me what 2 things I need. Someone besides Mazuka.
Point and a slope.
A point and a slope, thank you. So I'm gonna plug in a 5 pi over 12 into x. Sorry, Mazuka, I'm not hating, but I already know you know the answer to that question. And I'm gonna
I had my finger over the space bar because I was about to answer.
Oh, see, good thing. There's my happy face. All right, here we go. I'm gonna plug in the 5 pi over 12 in there. So I'm gonna go 2 sine 3 times 5 pi over 12. Chavez, you never taught us what sine of 5 pi over 12 is. Relax, relax. If you're like my sister, every time I tell her relax, she gets me even more mad. She's like, don't tell me to relax. Like, okay, relax. Like, and then she's like, ah, okay, anyways, I'll stop. So there it is. I plugged in 5 pi over 12. 3 goes into 12 4 times. And now you get this, 2 sine of 5 pi over 4. And this, you know, on the unit circle, 5 pi over 4 is right here in quadrant 3. And sine, well, really, they're being nice because it's a 4, so they're all going to be the same, right? Especially in quadrant 3. So you have 2 times negative square root of 2 over 2. The 2's cancel out, so you just get negative square root of 2. So my coordinate is 5 pi over 12, comma, negative square root of 2. Can we at least get that far? All right, now I need a slope. So to get a slope, I got to take a what? Yeah, derivative. Anyone can answer now. So here we go. I'm taking a derivative. So the derivative of 2 sine 3x is 2 cosine 3x, and I'm not done, chain rule times 3. If you wanted to in the very beginning, if you were to ask me this question the second semester, I would just immediately write 6 cosine 3x, but no big deal. 6 cosine 3x. Everyone pretty chill about that? So now, again, I'm going to plug in 5 pi over 12 to see what my slope is. F prime of 5 pi over 12. What did I write to? 6 cosine 3 times 5 pi over 12. Again, that's going to be 6 cosine of 5 pi over 4. And cosine of 5 pi over 4 is negative square root of 2 over 2. So 6 times the negative square root of 2 over 2. So they probably should have chosen a different angle than 5 pi over 12, but that's fine. So you're going to get negative 3 square root of 2. I stole this question. This one's from DM. But this one over here, I made up. Not this one, that one. Because I didn't want to make it exactly like DM. DM, I think, had like the x cube on the other side or whatever. This one I stole from DM, from Delta Math. All right, here we go. But you know what? Next time, I'm going to make up my own question, and I'm going to choose whatever angle I want. All right, I got my slope, I got my point. So y minus, I already forgot what my y value was. Negative square root of 2. So plus square root of 2 equals negative 3 square root of 2 x minus 5 pi over 12. Do you guys want to see a visual of this on Delta Math? Okay, you guys are going to have to tell me stuff because short-term memory here. So don't worry, I'm going to do it correctly this time, guys, so the virtual class can have the same experience. There you go, guys. See? Not everyone can see. All right, first I'm going to type in f of x. equals, and what was the function? 2 sine what? 3x? I would have thought it was, okay, I don't remember that, but that's fine. What is my tangent? Tangent, y minus plus. Yeah, y plus square root of 2 equals, oh, hold on. I gotta get out of there. Equals, what was my slope? 3 square root of 2. Get out of there. Open parenthesis, x minus 5 pi over 12. 5 pi over 12. Yeah, that does look like a, look at that, guys. And then give me the points again. 5 pi over 12. 5 pi over 12. And then move to the right, scoot. And negative square root of 2. Negative square root 2. Yay, look at that. Yep, that is most definitely a tangent. Very cool. I love how we can just go to Desmos and just plot these tangents and visually see them. I think that is so cool, right? All right. Guys, did you guys see all this good stuff? All this good? No? Okay. I
Yeah.
don't hear you. Okay. Thank you, guys. All right. Let's keep going. Now we got a table. Did we skip any? Oh, sorry. What did you say? I didn't hear. You okay, miss? Don't hurt yourself. Guys, I just saw Godinez take a bottled, one of those metal containers, and she just swung it to her head. You need to talk to Miss Cash? She hit her head pretty hard there. You need to go to the nurse, go for it. You went like this, miss. All right, take a 2-minute head start. See if you guys can do this one. I don't think you'll need 2 minutes. Let's do a 1-minute head start on this one. So here we go. I need to find the derivative. H prime of x. What rule do I got to use for this? Chain rule. Derivative of the outside. Leave the inside alone. Times derivative of the inside. There it is. So now I'm just going to plug in the number 5. H prime of 5 equals f prime g of 5 times g prime of 5. So first, look for g of 5. G of 5 is 12. So now it's f prime of 12 times g prime of 5. Excuse me. F prime of 12 is negative 4. G prime of 5. G prime of 5 is 7. 7 times 4, 7, 14, 28. So negative 28. And there you go, guys. Hey, guys, tell me, who was host when I was gone?
Carolyn's always like the host when you leave.
Were you guys like, I guess we'll just do the rest of calculus, or were you guys like, let's all just log off? Or no one said anything? Y'all are
No
fun.
one said it.
All right, guys, take a minute. Get this one done. All right, let's get started. Hopefully you're pretty close to getting done. It wants h prime of 5 again. Product rule. H prime of x equals first times root of the second plus the second times root of the first. Once you've done that, plug in a 5. F of 5, g prime of 5 plus g of 5, f prime of 5. And that's it, guys. We're done. We just got to get the values from the table. F of 5 is 11. G prime of 5 is negative 2. G of 5 is 12. F prime of 5 is 7. Hopefully I didn't make any mistakes there. So let's see, negative 22 plus 77, 79, 80, 1, 2, 3, 4, 84. Did I do that right? 84, 74, 64, 62. So I think I got 62. Did everyone else get that? All right, guys, we're almost done. We got 2 left. Take about, this one looks like it's gonna be about a minute. So take about a minute or at least a minute head start and we'll take care of this one right now, guys. All right, here we go. So this one's h prime of 6 or negative 6. So first I got to take a derivative. This is chain rule, derivative of the outside. Oops. Derivative of the outside, leave the inside alone, times derivative of the inside. So what I'm really looking for, negative 6, f prime of g of negative 6 times g prime of negative 6. All right, first thing you do, find g of negative 6. So here's the graph of g. Hopefully you can see it there. So negative 6, and I see a point at negative 4. So this turns to f prime of negative 4 times g prime of negative 6. Okay, so now f prime of negative 4, that means slope of f. So here's f, negative 4. So find the slope of this guy, of this line right here in red. Well, they're all red, right? Find the slope of this one in blue now. So let's see, 1, 2, 3, 1, 2, 3. It looks like it's 1. So that's a slope of 1. And then g prime of negative 6. So I need to find this slope of this blue line there. Let's see, does it look like it's perfect? Does it look like it's a negative 1? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep, it's negative 1. You can't trust it, guys. Sometimes you got to go by the coordinates. Because look at this. Oh, by the way, the answer is negative 1. Sorry, I was already going off on a tangent. Look at this. Good tangent, you get it? Okay. This line in green does not, it doesn't look like it. It looks like it does, but it doesn't. Does not have the same slope as that line in blue. If you look at it very carefully, it looks like the slope changes ever so slightly. So the only thing you can trust are these points. So let's see, 1, 2, 1, 2, 3, 4. So that slope is a negative half. Let's see, 1, 2, 3, 4. I bet you that's going to be like really close to half. 1, 2, 3, 4, 5, 6, 7. Look at that. That slope is a 4/7, which is not half. It's a little more than half. 4/8, 4/7. No, I think it's more because the denominator is 7 and not a 9. Do you guys see that? Negative, of course. So you got to be careful there, guys. All right, answer is negative 1. Last one. I think you just need a 1 minute head start on that one. So start. All right, guys, here we go. I haven't read the question, so let me read it. Let f be the differential function. So these are points, point. Oh, not all points, just those 2 are points. And these here in red are slopes, slope and slope. Let the function g of x equals f3 of x. Write the equation 9 times to the graph of g at the point negative 1. Okay, so I want a tangent line on g. So first get a point. G of negative 1 equals f of 3 times negative 1, which is f of negative 3. So I'm looking at that one. G of negative 1 equals negative 2. So my point is negative 1, negative 2. Did everyone get a point at least? All right, next, I need to find a slope. G prime of x equals derivative of the outside, leave the inside alone, times 3. Did we get to there? Did we get to there? So now, g prime of x equals 3 f prime of 3x. And we're just going to plug in. G prime of negative 1 equals 3 f prime 3 times negative 1. So 3 times f prime of negative 3. So we need this guy. So 3 times, if I didn't make any mistakes, that's 3 times 4. So I get a slope of 12. So my tangent line, so tangent is y plus 2 equals 12 x plus 1. Did you get that, Tiff? Good job, Miss. Godinez, did you get this answer? All right, guys, let's all come back real quick.